Hello everyone, you're welcome to the last video on statistics for engineers on normal distributions. So normal distributions are just the same thing as Gaussian distributions, credited to him. Okay, so basically normal distributions are, they try to explain most of what happens in nature, where you have a lot of occurrences of an event very like around the mean, and then you have few events at the extremes, right? So you don't find extremely good people and you don't find extremely bad people. Like people are mostly in between. I think that's like one way of explaining it. So basically what we are going to do with normal distributions is we are going to go with the shorter approach of solving normal distributions. But if it was um, the other approaches, right? So just for your reference sake, you could find this online or just in any book. Okay, so we have e power negative 1 on 2 sigma squared x minus mu r squared. Okay, so this long equation is what describes the, should I say, the probability density function. Yeah, so basically this describes the PDF of the Gaussian distributions. Now if you want to, so maybe this one you can put them in piecewise and then that would be complete. But then yeah, so basically that's just it. But then this one is quite complicated to work with, and you find that the major variables here are a and mu. The rest are just, and this one is your place of concern. But then the rest are just things you're familiar with. So these ones have values. All of them are numbers. But this one is the your your standard deviation, and then that's your mean, and these are the two major determining factors. So someone decided to simplify it down to what we call the standardized normal distributions. It looks like this. So it has a mean equals 0, then it has a standard deviation of 1. Now, so no matter the kind of information you have, whether the mean you find in your calculation is any number at all, using the new approach or the standardized approach, we'll just scale it down to this so that you can use your z-scores. Okay. So basically that's just how we get started. Now to understand how the mean and then the standard deviation affect this um, this whole graph, I'll just draw another one here. Then we assume that, so let's assume that this one is this, right? M equals 1, M equals 0, sorry. Now if you increase the mean, if you increase the mean, then it shifts to the right. So as your mean increases, then it keeps shifting to the right. So that means you can have your graph here anyway, right? And then if you decrease it, then it can come and look something like this. My drawing is bad. Something like this, right? And then with the standard deviation, if you increase standard deviation, what you are doing is that you are basically increasing the spread of your data. So as you increase the spread of your data, then it kind of spreads out, it flattens out. And then if you decrease it, then you kind of crumple your data together, then everything kind of goes up this way, right? Then you keep having like crumpled, or should I say, yes. So basically the idea is like everything kind of comes together in that sense. Now with this one, you are basically going to, so instead of going with this approach, now if you're going to with this approach, then you know how to find your standard deviation. So to find your variance, actually, which is just the same thing. So your variance, you find your x squared f of x dx. So you have to integrate that. And if you want to find your mean or your expectation, then you have to do integral x f of x, right? But then this is kind of a simpler approach that we are going to use. And then for the table we are going to use, I'll leave a link in the description so that you can just pick it up and print. So this is the table. So it's the standard normal distribution table, and now they tell us clearly that the values represent the areas to the left, right, of the z-score. So these ones, they represent areas, so they are not just numbers, they are areas. They are the numbers inside. And then these ones are your z-scores. Your z-score is basically, so your z-score is the difference between your point of interest minus your mean all on sigma. Okay, so this is your, sorry, so this is your z-score. Okay, So now let's just try to understand how this thing looks. So here you have your you have 0.0001 here, and this 0.9. So basically, if you are to find, if you have a z-score of say 0.93, right, then that means you have to pick 0.9, come and look for 0.3 here, 0.03 here. Then when you add them, you find that you have 0.93. Then this will be your z-score. In the same way, if you have a z-score of 0. Say 25, right, then you locate this one. It's not highlighting. Okay, good. Then till you get here, so you find that over here, then you have your area here. So this one will be the area to the left of the z-score, right? If one to the right, then depending on the location on the sheet, then you might decide to do a different computation, either subtract it from 0.5, because it's symmetric, so every side is half, or you can decide to add it to 0.5, or you can leave it as that. And then you find that it ranges from 3.9 to negative 3.9, and this is specifically for a reason, because for a number so to get a number like 4, then that means that this difference, so difference between a number and the mean should be basically like 4 times the standard deviation, which mostly it does not happen. It's because, so let's say you have a distribution of people, how old they live, right? And maybe you find out that people mostly live from ages of, say, let me say 1. People live from ages of 1 to, like, say, um let's just say infinity. Infinity is not a good number. Let me just take 200 years, right? So let's say this is the age you're considering. Then from the data we collected, we realized that um most people live up to 50 years. Then how possible is it that, so this will be your mean, right? And let's say you find your deviation, your standard deviation to be like, say, let me just say 2. Okay, now how is it possible for you to get 4? Let's just do that. So x minus 50 on 2 equals 4, right? So is this correct? Okay, so how do you get this? Then that means you do a multiplication, 858. So for this case, realize that your x will be something like 50. So this will be the extreme if the deviation is 2. But you know this deviation of 2 is so small. So let's say in a real life, this one you mostly have like high deviations. So let's say you have a deviation of, say 20, and then to get 4, then that means that you should be expecting someone to live like 130 years old, right? So you find that the higher your deviation, then the more likely, so the higher your deviation in real life, then it's possible that you won't even get to this 4. So for most things that happen, from negative 3.9 to 3.9 of a z-score would make sense. So basically, with this said, let's just get to it and see if we can solve some examples more. And I hope the way of reading the diagram was well explained. Okay, so let's see. Okay, so basically that's just it. Right, you can find numbers and then fit them inside and see how you calculate it. That's how it all works, right? Then let's just pick some examples from here. Okay, I think there's an example here. So it says that the return on investment. So this one has been solved already, so there's no need to solve it. So the return on investment is normally distributed with mean of 10% and a standard deviation of 5. And then they want the probability of losing money. So how would you lose money? And that means the only way you can lose money is if you have negative money, and then that will be less than 0, right? So that means I have to find the probability of the z-score, and then probability of the z-score will be this. Then that means you want z of negative 2. Now if you want to find z of negative 2, you just come to your table, so you find negative 2, and then you find that it's negative 2.0, right? So this is your number. So you have negative, so you have 0.02275. Then you come back here and realize that that's the number, right? Okay, right. So basically you find that that's, so the probability of z of that was basically 0.02275, and that's rounded to 0.228. Now, you realize that something was done here. You can decide to do this in exam, and you can decide not to do it, depending on if you understand how you are going about it. Now here, they use 0.5 minus this because it's a normal distribution, so every side is half. So this whole side is half, and you know that this is going left. So from here, you just have to subtract it from 0.5 because the whole of this side is 0.5, and then the whole of this side is 0.5. So depending on the direction they give you. Now, if they give, like, let's say instead of less than 0, let's say it was greater than 0, then something will change, right? Because it will have to move from here all the way there, right? And then that means is this small area that will be out of our computation. So how would you do this, right? So you can just find your z-score, and when you find out, it will just be that area. Then that means you have to subtract it from probably 1, okay, to get the rest of the area. That's how this one works, okay. And then there are some examples here. Let's just solve maybe the last two, because they're the ones that are looking. So let's just solve the last two and then leave the rest so that you can try and figure them out on your own. So if a random has a normal distribution, calculate the following. Okay, so if there are so we are going to work from using values here. Okay, so we are going to use a mean of 10% and then a deviation of 5%. Okay, so let's start. Okay, but you find that with these ones, it's possible that you can decide not to work them at all, right? Yeah, it's possible you can decide not to work them at all, because let's say if it's to the left, then you just find it, because you know that the z-scores, they take the area to the left. So what's the probability of this? So let's go to the table. Negative 1.7, we're going to find negative 1.7. Negative 1.7 is here, right? Then you have 0.4457. Then just so that'll be the answer for C. So for this one, now this is where you have some differences, right? So if you are working this one, then you'd have to be more careful. But if you are working less than, then so something like this, that'll just be your answer. But then for something like this, so let me just pick the direct opposite. So for this one, then you find that it will be this number. It will be 1 minus this number. Where is it? So it will be 1 minus this number, because of the direction it is on the. So basically, let me just do that on my sheet here so that you see how what I'm saying. So basically we have this, right? And then so you have z of say 1.7. Where do I put 1.7? Okay, so negative 1.7. Let me put it here, negative 1.7. Now so if you find z of negative 1.7, then that is everything here, right? So that'll give you your 0.04457. Good. Now if you want to find greater than this, right? So that means if you want the whole of this area, then you just have to subtract 1 minus z of negative 1.7, right? So that means that z, probability that z is not less than but greater than negative 1.7 will be calculated like this, right? So just take one from it. And then for the next one, there's another one here. This is the probability of negative 1.7 less than z less than 1.7. Good. So you realize that then it will have a replica here, right? Something like this. So basically you are looking for this area, right? Now how do you find this area? So basically there are two ways to do this, right? So first of all, you found you found z of that, then you could know that that's this area, and then since it's symmetric, it's also the same thing here. So this one is the same thing as that. Then maybe you can just multiply, you can just say 1 minus 2 times this, right? With normal distributions, then you get your 0. Probably 9, 9 what? You get 0.9 something, right? And then that would be your answer. So basically you realize that with these normal distributions, there are many ways to work it, a lot of ways to work it. Someone could say that they would find another phi, right? So they could find a phi. There's another table of phi. So maybe you can find phi of so you can say 0.5 minus phi of 1.7, right? And then since these two, and then this one will give you this area, this one. So this whole expression here will give you this, area. Then you do the same thing for the other one, then you get here. But you realize that if you actually combine them, if you add them, you realize that it's basically the same thing, because it lands up as the same thing as this, right? So basically normal distributions are just like that. So you just have to know how to use the table and find a way around. We'll solve another example, so I hope it will be clear by the time we're done with this video. So now let's take this other example here. So basically it says that the mean is 40, and then the standard deviation is 5. Basically this is all we need. So now let's start. So we'll have to find our z-score. So our z-score will be x minus 40 on 5. Now first thing is they said 43, so that will be 3 on 5, right? Basically it's 0.6, right? So basically this will be 0.6. Now z-score of 0.6, what does that correspond to? Now with these ones, right, it's very important to take note of the signs, right? So now if you see probability of x greater than 43, this one is different from probability of x less than 43. Now if they tell that probability of x equals 43, just know that it's 0, because we are dealing in ranges. So the possibility of just 1 point is basically 0. It reflects, it's similar to what we explained earlier for uniform distributions, right? So it's just the same thing. So now for this one, probability that x is greater than 43. Now if you want to visualize this, you could draw the, so there's 40 here, so you'd have 43 somewhere around here, right? And then the probability that is greater than 43 would be something like this, right? So now let's go and find and we have a z-score of 0.6. So let's go to the table and then find out what a z-score of 0.6 means, right? So I have it here, then we go. Okay, so z-score of 0.6, so locate 0.6, 0.6. Okay, and then you find that here we don't have 0.61, 0.62, so basically that makes it easier. So you have 0.726, let's just say 0.76, 0.726. Okay, now this one here is not this, it's rather this, it's rather the area here, because we said that it gives you the value to the left, right? So it's basically this whole area here. Now if you want just the area inside here, what do? Then you can just take 1 minus this, and it's also how you know how to like deal with these tables. So you can just take 1 minus this, and then that will give you the area here, basically. Or let me see. Okay, there's an approach too that was being used in class. So they were saying that the shaded area will be basically 0.5 minus phi of 0.6, and then so this one, right, this one would give you just this. So that means that this phi of 0.6, so if you subtract it from 0.5, then you just get this area. So that would be this area, right? I hope you get that. But basically that's not what we are dealing with. We just want to find the whole of this. So that would be like 0.3 0.374. So that is 0.374 for I. If you have a different answer, maybe you could just let me know. And then for the next one, so let's say probability at um, x less than, okay, so x less than 38. So for x less than 38, then that will be somewhere around here. And then, so if it's to the left side and it's less than 38, then just have to find the z-score. That will be a negative number, obviously. So your 38 minus 40 on 5. So what would this give you? This will give you negative 2 and 5. This will give you negative 0.4. Now you go to your table. So let's go to our table again. So I have to do this. 0.4. It's actually practically similar to 0.4 by then. So negative 0.4, you come here and then you see that it's 0.345. 0.345. So this one gives you 0.345. And then that's just your answer because it takes it to the left. So basically, there's just a maybe unless so less than 0.5 is less than 38, that'll be it, right? Maybe unless the two are greater than, then probably have to make use of one. And then, or if you want it with respect to the center line, right? Then that means you can take that area, right? You can okay, yeah, maybe unless they change the sign. So if they change this to like say greater than 38, if it's greater than 38, then you have to just subtract this from 1, and then that will give you the whole of that area. Simple as that. Okay. I think there are other examples. Okay, and then there's another one too. There's another. So at 40, you realize that 40 is the mean. So at 40, then what will happen? You have z score of 0, right? Z score of 0. Now we can go and see what a z score of 0 means. A z score of 0 means 0.5. Okay, let me enlarge this. So basically, a z score of 0 would imply 0.5, and then that would just be. And then, um, what again? Okay, but okay, so that's just it. And then your x greater than 23. So if x is greater than 23, then you locate your 23 somewhere around here, right? 23. Then you do the same subtraction again. Then that will give you like minus 17 on 5. Then you go onto your table. I think that'll be 3 point something. Then you find what the z score of that number will be. I think it will be like, let's just find it. So let's find it. Negative 17 on 5. Um, this will give us like negative 3.4, right? So negative 3.4. So with negative 3.4, let's go to the table and see what we'll get. So z score of negative 3.4. Negative 3.4. So negative 3.4, what is it? Okay, this is negative 3.4. We find it here, and then that will be 0.00034. Okay, so you find that it's a very small probability. So the probability, but then notice something, that 0 point something you had is this area, the area to this side, right? So now if you want to find the main one, then you have to subtract this 0 point something from 1, then you get the whole of that area, right? And that would be 0.99 something, and that'd be a big number. So with these ones you have to work with like approximately 4 decimals. I think I messed up the sheet, but then yeah, I hope it's making sense. So let's try another example. Let's and then please don't get confused, because in the slide you realize that the method that Dr. Percy was using was basically something like that. Yeah. So you have of your z, right? And then you should know where this one puts you, the area of this z, where would it put you? So if you are working with a normal distribution, um, we know that a side is 5. Oh, that's fine. Okay, so this is where approximately should be. So we know that each side is 5, 0.5. So if you take 0.5 minus anything, then that means you are taking into respect to this one. So if I find anything here, right? So let's say maybe a here. If I find the z score of a, it will give me this area. Then if I want to find with respect to this central point, then I just have to subtract it from 0.5, right? That's to the center. But then if you are dealing with the whole range of possibilities, then you can just subtract it from 1. So that's when you have to subtract from um, when you have to subtract from 0.5 and you have to subtract from 1. Okay, But if, yeah, but with this explanation, I hope if you have a question, you know how to go about with it. Okay, so let's try another example. Okay, so there are a lot of examples here. A lot of examples. We definitely can solve all. But then let's just pick the first one and see how we'll solve it. The first one. Okay, so it says that social organization number at least 74 feet. Okay, so at least 74. What's the percentage of men who are eligible? Oh, okay, I think we'll skip most of the question because this is part. So it says that men are normally distributed. So the mean height is 69 inches, and then the standard deviation is 2.8 inches. And now there is a club that has a least requirement of 74. So what's the percentage of men who can join such a team? So now you know that your mean equals 69 and then your standard deviation is 2.8. Now you are looking for um, people who can join with 74. So greater than or equal to 74. So basically this is what we are looking for. Okay, so let's just start with our hands and see how it goes. So we take 74 minus 69 on 2.8, right? And then if you compute this, this will give you 5 on. So 5 on 2.8, that will give you 1.79. So we have our z equals, so 1z greater than or equal to 1.79. Okay. Now, if you want to understand more of what is happening here, then you can always, so in exam, you can always do this. So you expect 74 to be around somewhere around here because here will be 69. Okay. And then, so now what do you want? You want these people. And this is clearly to the right. Now, if you find a z-score of this, so let's go and find a z-score of 1.79 so that you see the many ways of working around this. Z-score of 1.79. So now we have to look for 1.7 and look for 9. I think so 9 will be the last one. Oh, okay, so z will be so that will be the last one. So 1.7. So we have to look for 1.7 here. We'll find 1.7 here, and we trace it to the end. So you clearly see that. Okay, so that's it here. So this one. So you find that that is 0.96327. Okay. So basically, this is your z-score. Okay, this is not the z-score, right? The z-score was this. So now this is the area or the probability of finding someone who is less than. So basically, this is this. So probability of z greater than or equal to 1.79 equal to 1 minus probability of z less than or just less than 1.79. So this is what you just found. So this number is this, right? Now if you want to find everyone there, then you have to take 1 minus 0.96327. Then what does this leave you with? This will give you what? 0. What am I doing? So 0.3 368, right? So this will give you 0.368. So this 0.368 is now the percentage of men who are righty. Okay, I hope this is understandable. Now you find that the method that was used in class is 0.5 minus phi of say z of 1.79, right? Now phi of 1.79, if you check from the tables, that should give you 0.4633. Now all the phi is taken into respect to the center. Then when you subtract from this one, then you get 0.03. Sorry, so you get 0.03, the same thing, right? So basically, this is how it works. And then for me, the way I learn it is I use the diagram because it makes sense more visually. Okay, so you find that you can actually use each of them, any of the methods that is more comfortable to you, right? Okay, so let's get to the next thing. Okay. Um, okay, the other questions. So basically, Basically, let's just discuss how we solve these questions so that hopefully you can solve them on your own. So if a man is selected at random, what's the probability that he'll satisfy for the height limitation, right? If it requires between this and that. So from your table, right? So it requires 62. So 62 to like say 70, what? 76. 76 is somewhere right here. Right. So how many people fall within this? Then you can find it in two ways. You can find your first Z score, which will at 62, which will eliminate all of these people. Then your second Z score, at this point you have to be careful. So maybe at this point it will be more helpful to go with this method. So you have to find it probably to like so maybe you can, so the Z score you find here, it will be this small number. Then you can take 0.5 minus that that phi of Z1 here, right? Then this will give you this one because you're using 0.5 this time. And then when you find this one, right, then you find that it is, so when you find this one, the Z score at this number would basically include everything here. So you just have to take 0.5 out. So that'll be phi of Z2 minus 0.5. So you add these two up, basically, right? So that's how this would work. And then uh, okay, so these are all questions that you can. So basically, they're all in the same this one. Okay, and there is also this question here. I think this one we thoroughly solved it in class. Okay, so basically all of them take the same. So this is that if a policeman wants, um, okay, I think we can solve this I because it looks a little different from the rest. So it says that if the Newport Police Department wants to change the height limitation so that it only includes so that only the shortest 2% and then the tallest 2% are excluded. What are the maximum and acceptable height ranges? Okay, so we are looking at probability of 0.02 to the left and probability of 0.02 to the right. Okay, so we are taking out all those probabilities. So now, so this is like reverse calculation. So let's see how we do this. If you draw the graph would look like this. So this is what we are trying to do. So we are trying to get rid of um, 0.02 here, 0.02 here. So how do we do this, right? So that means that 0.5 minus um, phi of our z1, right, of our z1 would be 0.02. If you actually want, you can just solve only this one, right? You can actually solve only this one, and then so now here you solve this and say your phi of z1 will be 0. You bring it to that side, you get 0.48. Now this is not your final answer. Then you have to find z1 will be equal to phi inverse of 0. 0.5. So that'll be phi inverse of 0.48. Now how do you find phi inverse? I think from the same table, 0.48. So now I think this is where you have to look for um, closest values. Okay, so closest values, you want to 0.48. So let's come to the table here. So we're going to search for 0.48 and then see which one is closest to 0.48. So 0.48. So these are the areas. So that's why we are checking those ones. So 0.48. You find that this is pretty close. Where is it? Um, something is fishy. Okay, so you find that the closest here is this, and then that corresponds to negative 0.05. Okay, let's take it and see what it would mean. Negative 0.05. Okay, so I'm kind of checking this out to see if it makes sense. So the what we're getting is negative 0.05, then negative 0.05 equals what? Okay, negative 0.05 equals your first one, which is your x, which we are looking for, minus what was it, 69 all on 2.8, right? Then we have to simplify this down. So um 2.8 times 0.05 plus, right? So this negative plus 69. Then where does that leave us? Okay, so basically I think I don't have a calculator with me now, but then I hope it's not so wrong. 0 point it's 1 4 0.14. Okay, so basically you can cross check and see if it's wrong, then it will just be this one, right? Plus, I don't think this is right. Okay, so basically let's check back on the reading, right? Let's check back on the reading, because this will give you like just a few inches down, which will not make so much sense. So let's double check the reading of where the phi inverse of 0.48 falls. Okay, so um over here, I think the issue is finding the inverse of 0.48, an inverse of the area of 0.48. And I think from this particular graph where we have here, it makes sense to fall under 0.05. Yeah. But then for what I think an initial calculation I did, I had it to be negative 2.05. I think that's also Dr. Percy had in class. So I'm wondering where that issue is actually from. So yeah, but then basically, so that's supposed to be the method, right? So let's just go ahead and show how the method should be. Um, okay, okay. So basically, that should be it. Basically, that's just the procedure. But I just realized something. I just realized something why all of this is going wrong. Now, over here, right? I realized that like with the other method, it depends on the z table you are given actually, because the tables, I think there are two forms of it. Now over here, right? I think if we go with this, so we'd get. So let's say we wanted to find. We know that from this point, right? If you find the z-score, then that will give you this. So how about subtracting it from 1? Then that will be the whole of this area, right? So if you take, then that will be inverse of 0.98. So let's find the inverse of 0.98 on the diagram and see how that goes. So 0.98, the inverse of 0.98, the closest inverse we have. So now you have you are stuck between these two values, right? Because there's but then you realize that which of them is very close to 0.98. That would be the first one. Though this one is 0.8, it's greater than 0.8 by like 0.003. And this one is like 0.001. So we'll go with this one. So this one it has a value of 2.05, right? So if you work with a value of 2.05, then that'll be x minus 69. Sorry, 69 on 2.8. Then you can do your multiplication, and then you end up with, so 2 times 2.05 times 2.8 plus 69. So this will give you your value for the first. So that will give you about 74 inches, 74.74 inches. So this will give you, um, okay, I think the negative aspect. So that would be, okay, so basically, so if you work with this one, then this one is going to be the positive part. So probably that's going to be the z. So this one is rather the z2 instead. Then you negate this one, you have negative of this one, then you get the other side, which is going to be your z1. So basically this is how it goes. And I think the problem is with the table, right? So the table I'm using here, it's kind of, you get the right thing by working with one, or maybe I'm just working from a different perspective, but yeah, you get you get the right thing from working from one, because you realize that though it's symmetric, but then the numbers increase gradually, and then as they go to 4. So that's just the major difference in this whole calculation. Okay, so let me see if I get another example. Then we we check that and then finish up. So with this one, let me just make some conclusions, and then we see how to go around with this whole thing. Okay, so basically it will depend on your tables, right? So when you have your tables, make sure you check well to see the ranges of the z values. So whether they are taken with respect to the center, which is the mean, then that means you should be expecting values on the left and then the right to be. So values from on the left will be less than 0. 0.5, and the values on the right, the areas on the right will also be less than 0. 0.5. That's if you are considering it that way. That way you can be using the 0. 0.5 minus, or else you can be using the 1. So subtracting from 1, that whole idea was using, and then which will also work. But then if you're using that one, then that means you have to be more careful, because it might it's also quite so you have to be more careful on using it. Okay, so there was also an example about some some IQ stuff. So there was a membership for Mensa, which is a group for intellectually superior people, right? And then it follows the same same calculation. So you find your z score, then by taking the difference the of the number you are looking for, and then your mean, you divide by your standard deviation, and then when you do that, you get your z score. Then you go to the table, then find the corresponding value for the z score. Then that'll basically be your probability to the left. But if you want to the right, then you have to subtract it from 1, right? That's how it works. Okay, so finally, I think basically, I think there's an example here which is not solved. So there's an example here, right? So let's just solve this example, and then that'll be all for this part. So it says that a manufacturing process is used to make heart pills, right? And and it has a standard deviation of 0.1 milligrams of active ingredient. And then doctors tell us that a patient who takes the pill with over 6, okay, 6 milligram of active ingredients may experience kidney kidney problems. So that means that the maximum we are looking at to be 6 milligrams, and then the standard deviation is 0.1 milligrams. Basically, what we are doing here is we are looking for the mean, right? And then it says that you are asked to determine the target of the mean amount of the active ingredient in each pill. It shows that the probability of the pill containing the 6 milligram is very low, so like 0.0035. So we are going to solve for the target value of the mean, then we'll draw a picture of the distribution. Okay, so now let's get to it. So this is quite a so basically, first of all, you write down your parameters. So our sigma is 0.1 milligrams. Then our x, which we are concerned about here, is 6 milligrams. Then our mu is what we don't know, right? So we know that our z will be equal to x minus mu on sigma. So we know that our z here will be x, which is 6, minus mu, which we are looking for, on sigma. Sigma is what? Sigma is 0.1, right? This is what we are looking for. Now we know that the probability of z should be 0.0035. This is what we know. So what do? We need to find the corresponding z for this. Okay, then we fix that in, then we find our mean, right? So don't put this one in as z. Yes, so that means you have to find your, so if this is the probability of z, then you have to find, so this one is an area, right? This is an area, and then we have to find the actual z. So we have to look for this one on the table somehow. Okay, okay, so basically there are two ways to look for this, right? Now we know that there are we know that this one, it has two correspondents. So one of, so on the z table we know that the numbers they have like, so each one has its complement, and the complement is like always 1 minus that this one. So at this area, right, now at this area, if you draw the distribution, right, if you draw the distribution, and then we are concerned about 6 milligrams, so let me put 6 here, right, and then the mean, which is the mean we don't know, and we have a sigma here. Now we are concerned about some particular value, but then we have a z here, the probability of z to be this small number, which is also possibly around here, right? But then we are not concerned about this side of it, we are concerned about this side of it. So what do? You can just take 1 minus this. So if you take 1 minus 0.0035, then that gives us 0.99, is that correct at all? 98775, I think, I don't know, 65, sorry, I don't know if that's correct. Yeah, but basically that's just it. Okay, this one should be 9. This one should be 9. So sorry about that. So that will be 0.9965. Okay, 0.9965. Now for this number we have to find the corresponding z. So we have to go to the table. Right. So let's go to the table and find 0.996 0.9961. Okay, so let's go. 0.9965. And when we are done, we'll try with the other one to see how that will make sense. So 0.9965, how do we find that? So we have 9966 here, good. 9965, this is good. So we have it here, right, which is this. And we have 9952, I don't know. Okay, so basically this one won't work. So I think these are best guess, right? These are best guess. So we'll take the value at 0.99653, and then that has a z score equals 2.7. Okay, now if you did not go with that one, right, and you decided to go with the 0.0035, you'll find it in the negative domain. So 0.003535, where do we locate that? Okay, exactly. So we got negative 3, so it corresponds to negative 3.3. Okay, good. Now, one thing you have to take note of is that you have to really understand what these values all mean. So now let's work with this one. Right? Let's work with this one and find out. So 2.7 will be equal to 6 on 0.1 minus mu. So you multiply it and you have 0.27, right? And then what else? So 0.27 equals 6 minus mu. Okay. Okay, then we get our mu equals that. So you take this one here, bring down here, that'll be 5.73. Okay, so 5.73 will be the standard, the mean, right? Milligrams. So that'll be the mean for the calculation we are looking for. Okay. So basically, this is how you go around with it. Now, what are the possibilities? So let's say you decided to try with negative 3.3. What will you get? You find that would literally not make sense, because the mean will be greater than what you're trying to prevent. So here, just look at it. So you put negative 3.3 here, you get negative 0.33, right? And then when you arrange, that will go here. So that will go like 6.33 being the mean, which does not make so much sense here. Okay, so basically I think this is everything about normal distributions. Okay, I think there's a last question. There's a last question on. Okay, so there's a last question that we should draw a picture of the normal distribution we came out with to show 3 sigma limits. 3 sigma limits. Okay, so let's see what this one means. Sorry. Okay. When we're talking about how to get 4 for um I don't know if I still have that paper, how to get 4. Okay, I think I've misplaced it, but then yeah, so let me just explain what how we are going to get a sigma limit, right? So to get a sigma limit, then that means you have to um, take that number of sigma limits you want away from the mean, basically. So here, if we draw this, so we know that here is 5.73, and when 3 sigma limits away from it, then that means, so the mean here plus 3 times sigma, and then from here the mean minus 3 times sigma. Those are just sigma limits, that's all. It's nothing special about it. So mu plus 3 sigma, which is 0.1, then that will take you to like 5.43 here, right? So 5.43 here, and then of course, yeah, and then as a point, that give you like 6.03 here. So basically, when you draw a graph, it should look like this. So this is the graph showing 3 sigma limits. And then you can decide to put your line in the center, basically. So this will basically be it. And then yeah, so just that's all. Maybe just have to know how to represent it well, so you can represent it better, right? Yeah. So basically, this is, so maybe you can call this one your probability of Z. Call this one yours. What? Um. Wait. Okay. So sorry. This one will be. I think this will be your values, right? So this one should be from your probability of Z. Making so much sense. So basically, I think I'm kind of messed out on how to, but then we know that the, so since the mean is here, then this one should be your values, right? Your, but then because um yeah, so this one should be your values, so that would be your x values, right? And then what will be their rise, or basically, well, so that's just it, right? Basically that's it. I was just trying to make more sense of it, but that's how to calculate it. Yes, so basically that is all on standard deviation. This is really long, but I hope it's helpful. Then you can find more material online if this is not enough. Okay. So thank you very much, and it's been great doing these videos and uh, having to go through all the long calculations and mistakes. But then, um, if you find any error in the calculations I make, please do well to put it in the comments, and then I'll be sure to check it out and then reply to you. So thank you very very much for the motivation to continue doing these videos. Is very important. Right. Thank you, and all the best in the exam.